Hello, everybody. This is Professor Jason Kim. Today's lecture is on chapter 3, mainly about average and the variation. The average that we know in statistics, we call mean value. And variation is how much you are away from mean value. So those are the two main topics that we're going to learn. In chapter 3.1, we are talking about the central tendency, the center value, which means middle value that we are talking about. So average represent the middle value, and variation represent the how much you are off from the middle value. So now let's talk about the middle value first, measure of central tendency. There are three different way of finding a middle value, central tendency. One we call mode, the other we call median, and the other one we call mean. So mode and media and mean or mean value try to show the middle value from the data they gave you. So now the average is an attempt to summarize the set of data using just one number, which means like middle value, center value. There are many ways to compute the averages, but from them, the three terms, three vocabulary are the mostly used to represent the middle value. Mode is the data value that is most frequently shows in the data. That's the mode. Median is central value in ordered distribution. So it's talking about the value that is in the center. Doesn't matter what it is, but value that is in center. That's median. But to get the median value, you have to know a position of the medians. Since it is smack in the middle, you have to know where from this old data, population data, or even sample data, where is the position of the that median values reside. So formula to get the position of median is n plus 1 divided by 2. Okay, or if you have odd number data, the middle data, you have a one position of middle data. If you have an even number of data, you have two positions. So to represent the middle medians. So the way you do it is after you find out this two position, you add this two middle number and divide by 2. So I will show you example, but the quick example is if you have a 1, 2, 3, so how many number you have? 3 numbers. The median would be 2. But if you have 1, 2, 3, 4, how many number do you have? You have 4 numbers. You have even number of numbers, 4 numbers. Then where is the median? Well, there is no one middle location like we had 2 when you have 3 numbers. We have 2 of the middle number here now. So what you do is you get an average of this. So you add 2 plus 3 and divide by 2. So it's a 5 over 2. So your median value becomes 2.5. Your median position is 2 and 3. Okay? That's what they're talking about. Now, the mean is mean value or mean is the one that we known as averages. So you add all the entries, all the data. So you sum them, and then you divide by number of data. Okay? So that's what we used to know as an average. There are two kinds of means. One is sample mean, and the other one is population mean. So when you have sample mean, we call sample statistics. So X bar is the symbol that we represent the sample mean, which is sample statistic, is summation of all the x's, which means x represents each value of each data. So your summation means you're adding all the input data and divide by number of item, which is size of the item. So you use n for sample statistics. Now for the population mean, we call in technical term population parameter, which is mu equal summation of all the x's divided by size of the data n. So that's the formula that we use. They look very similar, but a little different. But this is the mean value or mean parameter of population data, and this formula is mean value of sample data or sample statistic. So let's look at the examples. You have 1, 2, 3, 4, 5, 6, 7. 7 test score for 5 classes. So first class, you have 100, 55, 55, 55, 50, 50. Second one, you have second class, you have 100, 100, 100, 100, 50, 40, 30, 50, 50, and on and on and on. Then what is their averages? What is their mean value? Okay. So mean value of first one is 60. Mean value of second one is 60. And 60, 60, 60. So all of them mean value, average value is 60, even though their distribution of each individual score looks different. But they are all 60s. So we need some like middle number or value that represent each class, even though they look different, but they're all 60s. Okay? So when you add the individual entry divided by 7, then you will get all 60s. So now let's look at the example. Find the information from the following data. You have 100, 100, 50, 40, 30, 55, 50. So what is your n? It's a sample, so 1, 2, 3, 4, 5, 6, 7. N is 7. You have 7 data entries. Now, what do you do? Well, first thing you do is when you have a data, it's always good to have rearrange this in ascending order. So you write 30 is the smallest number. So I usually circle the smallest number. And then 40, 50, 50, 50, 100, and 100. And last number, you circle it. And then you count it 1, 2, 3, 4, 5, 6, 7, and double check with n size. So I have 7 and n was 7, so I didn't miss any data entries when I did when I rearrange in ascending order. The reason why you change into ascending order is the data looks much what do you call easy or efficient to see the progress of number. Okay, that's why. Now, in number one, mode. What is mode in this data set? Mode, by the definition, is the most frequent number. So, is there any number that appears most time? Yeah, 50s. You have 350s and 200 and one of each in 30 and 40. So mode definitely going to be 50. And position of a median. So what was the formula to get a position of a median? Formula was n plus 1 divided by 2, right? And since n was 7, it's a 7 plus 1 divided by 2, 8 of 2, which is fourth. So what does that mean? The fourth value is the position. Fourth is the position of a median. So first, second, third, fourth. So that's the position of the median. So answer is fourth position. And median value is any value at that fourth location, which is 50. Right? So answer is fourth. And median value is 50. That's the value at the fourth position. Mean value is you add all this entry, 30 plus 40 plus 50 plus 50 plus 50 plus 100 plus 100. And divide that by 7. That's how you find that the mean value. So if you use a calculator, if you add them, you got 420 divided by 7, and you got 60. So your mean value is 60. So when you compare mode and mean and median and mean value, they could be same, they could be different, but it's not that different. Okay? Especially when you have a small size data. When you have a much larger size data, it might be a little different, but still it's very, very close enough. So they all represent the central tendency, middle values. Okay. So now you have a solution here, which I just explained it. Okay. So now let's have a little larger size of data. Find the information from following data, 10, 14, 4, 5, 11, 14, so on and so on and so on. So how many data do I have? I have 2 of each. I have 2 of each with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have n as a 20. That's the first thing you do. And step 2, I have to rearrange this in ascending order. So what is the smallest number? Smallest number here was 4. Okay. So I'm going to cross out 4. And then 5. 1, 5. 1, 6. And 1, 7. 8. 9. 10. So far I have a 1, 2, 3, 4, 5, 6, 7 numbers. And then I have a bunch of 11. 1, 2, 3, 4, 5, 6. Oh, I have a 6 11s. So I'm going to write 6, 11. And then I have 2 12s here and here. and I have a 13, 14, and one more 14, and 15, and 16. So I have 20 of them. So when I count it, it's a 20. Smallest number was 4, and largest number was 16. So what is the mode? Obviously, I have 6 11s. So mode should be 11. What is the position of the median? M plus 1 over 2, right? So 20 plus 1 over 2, 21 over 2, which end up with a 10.5. So what does that 10.5 means? 10.5 means the position would be between 10th and 11th position. So you have a two median positions. So 10th was 11 and 12th was 11. So, but position of median is 10th and 11th, 10.5, or you write 10th, between 10th and 11th. And median itself is you get 10th value and 11th value and divide by 2. This happened to be 11 plus 11 divided by 2, which is 11. So 11 is median, and again, it's a 10.5. Or you can say 10th and 11th. Either one is fine. Mean value is, again, adding all this. 4 plus 5 plus 6 plus on and on and on until 15 plus 16 and divide by 20. So when you do that, you get 211 over 20, which is 10.55. So you got 10.55. So when you compare the actual value of mode and median and mean, they're all sort of somewhere near 11. So it's fair representation, even though the smallest number is 4 and biggest number is 16. Somehow they all are directing a somewhere in the middle as 11 or 11 and 10.55. So you have to know definition of mode, median, mean, and you have to know how to get that value of each vocabulary, each central value, central tendency. Okay? So that was section 3.1. Now, section 3.2 is not a central tendency. We're talking about the variation. Okay? Variation is spread of the data around center. That's what they mean. The variation is how much you're off away from the central tendency. That's variation. So in statistics, that mean value or central tendency value is very important because that represents the characteristic of the whole data. So mean value become very important. And then when the people who study statistics, statistician, realize that how much you are away from the center of each value means something, or gathering of how much you are away from center or spread from the center value become very important. So they start studying about these variations. Now, before we do that, we have to know what the range means. Range is a difference between largest number minus smallest number. So that is telling you, excuse me, the range of the data. So in previous question, range of the data was smallest one was what, 4, and largest one was 16. So 16 minus 4, which is 12, is the range of the data. Okay. So that's the range. And another vocabulary you have to know, or symbols, are something regarded with variations, variance, and standard deviation. Before I continue further, the relationship between variance and standard deviation is very simple. Variance is just spread or how far from center, represented as a sigma square. But we don't want to have a square value. That's why they have a standard deviation, which is, we say as a SD, standard deviation is square root of variance. So standard deviation becomes square root of sigma square, which end up with a sigma. The relationship between standard deviation and variance, which both represent a similar concept, which is how much you're away from the central tendency. But the variance is sigma square, and standard deviation is square root of variance, which end up with a sigma. So now let's look at the vocabulary again. X. What is X? X is a data value, okay, or the input data. Okay? And mean is central tendency. And how do you get that? You add all the x's and divide by n, average of data value. That's mean. Then what is x minus x bar? X minus x bar is, x bar was what? Mean. The difference between input data and the mean value. So the difference become how much you're off from the mean value. So it's a difference between what you expected with what happened. So x is what happened, and x bar is what are you expected. Mean value is always the expected value. Okay, so this represents a deviation away from what you expected, because mean value is whatever the middle value, which means what you expected the value. But individual could be different. Individual could be 4, individual could be 14, 16. Okay, so getting a difference means something. How much you are away from the center mean much. Now, so what are we doing? We try to find the formula, okay, of sample variance. So it end up with formula of variance is summation of the difference square divided by n minus 1. That's variance formula. So you have to know first the difference, and when you square the difference and add all together, you get total value of differences, difference square actually, and you divide by n minus 1. So somebody or group of people who study statistics create this formula. Well, in that time, they can really spend time on one thing. So they study hard, and then they made this formula of variance. And then later on, this change to more efficient way, which is summation of x squared minus summation of x whole thing square of n divided by n minus 1. So they create this two. So this is by the definition, and this is more efficient to calculate the value when you have a large number of input data x. Okay? So that's the formula. You do not have to know how they developed this formula, but you use this formula to find the variance, which means difference from how much your difference from center squared, and getting average of that. So you don't have to know how the automobile works, but you use handle and brake and the accelerator pedal, and you drive around. So same thing. You do not have to know how this has been created, but we are using this to find the value of a variance. And then you get standard deviation by square rooting a variance. Okay. So S become standard deviation of sample data, sample statistics. So that's what here variance, and this one is the middle one. You get summation of sum of squares that makes the reason why square is to make a non-negative value, because sometimes you get a negative value, but when you scale them, when you get a difference between x and x bar, sometimes you get negative value. But you have to square them. By doing a square, you get rid of non-negative. Aha, so they have a philosophical background about this. Square them to get rid of negative. Okay? And then you have a sample variance of x as a s square, and then you get a standard deviation of s, which formulate with either this or that. So what was the difference between these two formulas? This was created by definition, and this was they changed around to easier to calculate the larger number of data. So you can use either one of them. And I use this particular formula to find the standard deviation throughout this particular chapter. Okay. Now, making sure you understand the difference between this and this. So summation of x square is you square them and add. You square the difference and then you add. Or square the x value, you add. Summation of x whole thing square means you add first. You summation x, add all the input value. And then after you finish them, then you square. Compared to first one is you square each one and add them. So they are a little different. Okay, so I want you to recognize the differences. So so next reading is about the summary of what we just did. What is range is telling us, what is sample standard deviation is about. Okay. And when you have a population parameter, which means dealing with the population data, they are very similar. Okay. And so here is a formula for population mean, how to get the population mean, and this is a formula for the population variance, sigma square instead of s square. And here is a formula representation of standard deviation of population data. Okay. Now we're going to do some practice on this, so hold your breath for a while. Now, the next topic is formula representation of coefficient of variance. Sometimes you want to find out the coefficient of variance in percent. So in sample data, coefficient of variance is always S divided by X bar times 100%. So what does that mean? That means you have to get what? Standard deviation first. And then you divide that by mean value. Okay, since it's S and X bar, I guess they are dealing with the sample data. Okay, and then you multiply by 100 to get the percentages. So coefficient of variance are needed sometimes to analyze your data better. And this is the formula you use to find the coefficient of variance of the sample data. And this is the formula of getting a coefficient of variations, I'm sorry, I keep saying that, of population data. They're exactly the same, except the symbol look a little different. So now let's look at another example. Find the information from the following data, 10, 10, 5, 4, 3, 5, 5. What's the range? Again, you find what is n. Size was 1, 2, 3, 4, 5, 6, 7. 7. Number 2, rearrange the data in ascending order. So smallest one is 3, 4, 5, 5, 5, 10, 10. And then you count one more time after you circle the last one. 1, 2, 3, 4, 5, 6, 7. So you didn't miss anything. So now they didn't ask, but hey, what was the mode? 5. So mode was 5, even though they didn't ask for it. What was the position of a median? There was a n plus 1 over 2, so 7 plus 1 over 2, which is a fourth. What is actual median value? Whatever the value at the fourth location. So first, second, third, fourth. So which is 4, 5. Number 4, what was the mean value? You add 3 plus 4 plus 5 plus 5 plus 5 plus 10 plus 10. Divide by 7. So when you actually add them, 20, 30, 39, 42. So unless I made a mistake, it's a 42 over 7, 6. So mean value was 6. So mode was 5, so you circle them. Median is 5, and mean was 6. Okay? Does it mean always bigger than median and mode? No, not necessarily. It just come out that way. Now, how about range? How do you find the range? Range is the largest number minus smallest number. So in here is 7. Largest number was 10, smallest number was 3, so on and so on. Now, how do you find the variance? Well, you make a table of 7 data. So xn, you have to find the x square. So you write this, rearrange it in ascending order, x value first on the top. X was 3 and 4. So these value I'm going to write down here. 3, 4, 5, 5, 5, 10, 10. And then you have to get a 10, x square. X square is 3 square, which is 9, and 4 square is 16, 25, 25, 25, 100, and 100. Okay? And then at the end, what you do is you try to find summation of x, which means adding all these numbers. Adding all this number, I said it was 42, right? I got it from previous question, 42. Now I have to add summation of x squared, which means I am adding x squared value. So 9, 16, 25, 25, 25, 100, 100. So when I do that, I got 300 unless I made a mistake. So why am I making this table? Because in number 6, they're asking for find out the variance. This is s squared. And the formula of getting s squared is a summation of x squared minus square of summation of x divided by n, and divide the whole thing by n minus 1. So to plug into each of this, I need this table. So you have to have a table when you do it this way. So what is summation of x squared? Hey, here it is. Summation of x squared, which means sum of all the x squared, it was 300. So you replace that or substitute that as a 300. Minus, what is a summation of x, which is 42. And you're supposed to square them and divide by n. And what was n? N was 7, right? That's, see, I said that here, 7. So you divide that by 7 and divide the whole thing by what? N minus 1, so 7 minus 1. So that's how you find a variance after you make a table and get a summation of x and summation of x squared. So this formula looks too complicated. Yes. And this formula have a very good chance of making a mistake. Yes. So I'm sharing a how not to make a mistake. Okay? How not to make a mistake. You do like one at a time in order of operation. Okay? So you always do square first. You always do numerator and denominator separately, one at a time, like that. So in this case, you do this first by using a calculator. So what you do is you square the 42, which means 42 times 42, and divide by 7 first. I hope you got 252 when you do that. So you rewrite this whole thing as a 300 minus 252. Okay? And obviously 7 minus 1 is 6. So don't do in your head. You write it down. And always double check either your calculation is correct. And then you do numerator, which is 48 divided by 6. And then you get 8. So you do step by step and write all the detail, okay, when you do this kind of question. So that's the variance of this data, 7 datas. Then how'd you get number 7? Standard deviation. You get standard deviation by putting S as a square root of variance. What was the variance you got? 8. Square root of 8. So when you have square root of 8, by using a calculator, you end up with a 2.828. 2.828. Okay, so your answer becomes 2.828. That's the standard deviation. So that's how you find a range and variance and standard deviation. And rest of the other ones like mode mean and median and more means. So on the test, I give it the question like this. So you should be able to find the answer, and circle the final answers. Okay? And also, sometimes I ask how to find your coefficient of variance. Okay? The formula was what? Standard deviation divided by x bar, mean value, and times 100, right? So that means I just found the standard deviation. That was 2.828. So you need to find the median. Median was what? According to my calculation, median was 6, right? So if you plug into here, S was 2.828 and X bar was 6 and multiplied by 100%. Okay. So when you do that, you got 47.133. So that become your coefficient of variance. So it's like progressing it. You cannot just get a coefficient of variance without getting standard deviation or without getting mean values. So you have to get a mean value first, and you have to get a standard deviation. Then you can get a coefficient of variance, okay? Which is you're dividing the difference of central tendency by mean value. That was actually another name for coefficient of variance. So if you make a mistake to getting either mean value or standard deviation value, then you obviously get a wrong answer for coefficient of variations. So making sure you always double check your calculation, so if you don't make any mistake. And when you get a decimal value, try to get as many as possible after decimal place. Okay, so try to get like 3 or 4 digits after decimal places if you can get that. So that was one example, and then I have some exercises. So this will be a homework. Do this exercise for number 1, and which is getting a mode, position of median, mean value, range, variance, and standard deviation. Ooh, I forgot to put a coefficient of variation. Oops. Okay. Anyway, so that's number 1. Exercise number 2, I have another set of exercise to do it. So please do that as a homework. And I emphasize one more time the important concept in this section. Okay. Now, I'm going to skip chapter 3.3 since that was optional. And I have more exercise as a homework exercise. Previous was 1 and 2, now it's 3. Okay. So when you do this, they want to find this 10 answer. Among this, only thing I didn't explain was Chebyshev interval. All other 9 questions, I explained it. So number 1 is find those 10 answers by using these X table values: 7, 8, 9, 5, 10, 11, 11, 6, 11, 4. So find the 10 information from section X data. And number 2 is find the 10 information, so those 10 questions, answer those 10 questions with the now Y data. So X data has a 10, so N should be 10 here. And Y data has another different 10. So it's just like practice. The last one is find the 10 information of XY data together, which means now N become 20 because you're going to use all the data from 7 through 11, all the data, 20 data. So the purpose of this 3 exercise was you doing repetition of those 10 questions with the 10 of X data, 10 of Y data, and 20 of XY data. Okay? And I have another exercise of this. Again, with a 10 of X data and 10 of Y data and 20 of XY data. I'm sorry, but another exercise. I have a plenty of exercise. So all those are the homework, doing all the exercises. So only practice make it perfect. So keep doing it, and after you do that, check your answer with a solution key. Okay. I'm sorry I gave you too much homework, but I want you to be acquainted with and perfect on this kind of question. Okay. So that's the end of chapter 3. I will see you in a class, and be safe and be healthy. I will see you soon. Okay, take care.